Good morning, children. Today we'll start a new chapter, pressure in fluids and atmospheric pressure. Before that, let's talk about thrust. Okay, thrust is a new quantity you're hearing. So let's talk about thrust. So we know that force can be applied on a surface in any direction. Okay, force is a vector quantity. It can be applied on a surface in any direction. But if the force is applied normal to the surface, then that force is called thrust. So thrust is a special kind of force which acts normally on the surface. So any force which acts normally or perpendicularly on the surface, that force we call it thrust. So force and thrust is the same thing. Okay, therefore the SI unit of thrust is the same as the SI unit of force, which is Newton. And let me give an example. If a person is standing, okay, on the floor, then the feet of the person is applying force on the floor normally. That means the person is applying thrust on the floor. Okay, let's say the person is applying thrust 50 Newton. That 50 Newton will be equal to the weight of the body, because as you know, the weight is same as the force applied by that person on the floor. Therefore, thrust exerted by a body on the surface is equal to the weight of the body. As I told you, SI unit of thrust is Newton and Celsius unit of thrust is Dine, and relation between Newton and Dine is 1 Newton equals to 10 to the power 5 Dine. Okay, so there are other unit, SI MKS unit, or which is kgf for the force or thrust. Celsius unit is gf, and we have a relation between 1 kgf equals to 9.8 Newton and 1 gf equals to 918 Dine. So in terms of kgf and in terms of gf, we can express force or thrust. Next is pressure. So what is pressure? Pressure is equal to the thrust per unit area. Pressure is the thrust per unit area. So pressure depends upon two factors. One is thrust, another is area. From this relation, thrust or force, thrust or special force is in the numerator and area is in the denominator. So from here we can see more is the force, more will be the pressure, and lesser is the area, lesser will be the pressure. Okay, so more is the force, more is the pressure, lesser will be the area, more will be the pressure, because area and pressure has inverse relation, whereas force and pressure has direct relation, because force is in numerator and area is in denominator. So whenever the force increases, pressure will increase. Whenever the area increases, pressure will decrease. Or whenever the area will decrease, pressure will increase. And what is the unit of pressure? SI unit of pressure is Pascal. SI unit of pressure is Pascal. P-A-S-C-A-L. Pascal. Okay, and the symbol of Pascal is capital P-A. So this is how we represent Pascal. Just like the symbol of Newton is N, capital N, and symbol of meter is small m. So here with this relation we can say unit of pressure equals to unit of thrust by unit of area. So 1 Pascal will be equal to 1 Newton by 1 meter square. Understood? So 1 Pascal is the pressure exerted on a surface area of 1 meter square by a force of 1 Newton acting normally on it. Okay, so this is it. So 1 Pascal pressure is a force exerted on 1 meter square area by a force 1 Newton acting normally on it. Again we have so in case 1 Pascal equals to 1 Newton per meter square. So there are Celsius unit also, you can see the Celsius unit of Newton is Dine, Celsius unit of meter is centimeter, therefore Celsius unit is Dine centimeter square. Okay, other units of the pressure, there are other units also, which is bar. So 1 bar equals to 10 to the power of 5 Newton meter square. This is the relation between bar and pressure. Okay, this is the relation between bar and pressure in terms of SI unit. So Newton per meter square is the SI unit. So 1 bar equals to 10 to the power of 5 Newton per meter square. Okay, another unit of pressure is atmospheric, also we call ATM. 1 atmosphere, in terms of atmosphere also we measure the pressure. 1 atmosphere, 2 atmosphere. Okay, that way 1 atmosphere is the pressure exerted by pressure exerted when the barometric height is 76 centimeter of mercury or 70.76 meter of mercury. So at normal temperature and pressure, the barometric height is 76 centimeter of mercury or 0.76 meter of mercury, and at sea level, which is taken as 1 atmosphere. So this 1 atmosphere is the pressure, exert pressure when the mercury height becomes 76 centimeter. And there is a relation between 1 atmosphere and Pascal. Pascal is the SI unit. So 1 atmosphere equals to 1.013 10 to the power of 5 Pascal, which is almost equal to 10 to the power of 5 Pascal. So 1 atmosphere is equal to 10 to the power of 5 Pascal. Sometimes they ask the questions in the numericals, they would give you the pressure in terms of atmosphere, 5 atmosphere. So always you have to convert the atmospheric pressure into Pascal. So 5 atmosphere equals to 5 atmosphere, 5 into 1.013 10 to the power of 5 Pascal. So convert 5 atmosphere into 5 Pascal by this relation, 5 into 1.013 10 to the power of 5 Pascal. Okay, so another unit is torr. 1 torr equals to 1 millimeter of mercury, and 1 atmosphere equals to 760 torr. Okay, so these are the relation of Pascal, of pressure.